Production floors' primarily focus has long been to deliver optimum output, to not only include the company's products, but to communicate data that enhances the business agility, ultimately their profitability. I'll briefly review why a robust physical infrastructure enables convergence with enterprise, and with an example of how one leading metal processor implement a structured, engineered approach to ensure the company's investments in network distribution delivered optimum output. Following the presentation will be a question and answer session led by a local Panduit, Australia individual. Every organization today is being challenged to transform from what we've been to what we need to be. And that transformation only takes place when we can build technology into our business systems, those emerging technologies as part of the way we do business. McKinsey characterizes that for markets like North America and Europe and other established manufacturing-centric economies, that the growth of GDP will only come after the do-it-smarter companies that will build a better business model and reap the benefits of innovation and business agility. There is evidence all around us that industrial networking and industrial Ethernet is becoming more and more pervasive. There are estimates that 100% of plant floor devices will be providing data of some sort as soon as 2018. And as availability of Ethernet-enabled devices increases, we are seeing nodes grow. Looking at the current numbers, 160,000 new nodes are being added every day globally. What is also happening is that the industrial IP networks are becoming a network fabric that easily and securely connects vital services, better enabling a variety of services from industrial computing and the cloud, wireless, video, remote and mobile access, energy management, safety, and security, making companies more competitive and building value. This drive to connect devices to gain value is captured by the concept of the Internet of Things. The value at stake over the next 10 years is calculated at $3.9 trillion in innovation, efficiencies, employee productivity, asset utilization, and improved customer experience. So as the role of industrial network is changing, we need to adapt how we design, install, and maintain these networks to reduce risks and reap the opportunity of IoT. This data demands fuel greater and greater needs on manufacturing. Evaluating the impact of IoT on a manufacturing operation starts with an evaluation on the processes. It may look like a brand new factory, or perhaps the need to make the existing one bigger, both leading to more network infrastructure and more visibility into manufacturing operations to increase efficiencies and output. Identifying where the network is suffering reliability issues, manufacturing downtime, outgrown existing equipment, regulatory requirements, and the constant need for more and more data really calls on a team of individuals to sit down and sketch out or whiteboard the requirements necessary. So we're seeing another transition occurring. Industrial networks are becoming much more of a discipline, a standards-based approach to deploying a control system. As a case in point example, Aberdeen has done some research and helped define the profile of a best-in-class manufacturer, industry average and those that lag behind. The research covers many areas, but the one I'll focus on here relates to the importance of the physical layer to business performance. What was revealed here is that those defined as best in class are putting greater emphasis on network management and taking greater steps to ensure network reliability and resiliency. This would include steps taken like utilizing redundant devices, building in redundant paths so that a single device or link failure does not take down the entire network, understanding the importance of having a cable management and wiring strategy for the physical design, ensuring data speed is maximized throughout the network. So the defining criteria that profiles these manufacturers as best in class includes 8 hours downtime or less, 11% reduced total cost of ownership, 90% or greater OEE, and a 25% increase in operating margin. The point here is that infrastructure is critical to meeting performance goals, and good methodology provides results. So now let's take a look at typical spends on the network. Software, about 60%, networking, 23%, operations, 10%, and cabling infrastructure, 7%. Look also at expectation for lifespan and turnover. IT budgets spend most heavily on software and hardware, with very small percentage of the budget going to cabling. However, up to 80% of network problems, which manifest themselves as other problems in the application, can be traced back to cabling. The tendency to correct issues is to go after a simplest approach possible. This can cause waste in capital budgets as unneeded devices are replaced due to difficulties in troubleshooting. The other thing to notice here is the turnover on equipment versus the physical layer cabling infrastructure. A company may upgrade networking equipment 4 or 5 times over the life of the cabling infrastructure. It pays to be forward-looking when planning the cabling used. So here are some examples from the real world. These are always amusing to look at, and it happens to the best of us, but these are not fun to live with. The guidance of standards-based approaches in the physical design is critical to avoid these types of situations, avoiding network sprawl, troubleshooting nightmares, safety and security issues by using a structured and standards-based approach. Planning early for the physical network infrastructure is a critical factor to providing long-lasting and cost-effective deployments. Why we have a tough time correcting these real-world situations is that late in the game is very expensive to fix. A $10 fix in the planning stage turns into a $10,000 full-blown crisis when fixed out in the field. A problem in the late stages leads to missed deadlines, overtime costs, costs to bring in outside personnel, travel, entertainment expenses, etc. A strong physical network design guided by standards and reference architectures is very important to provide reliability and reduce risks right from the moment the logical network is known. Turning your network vision into reality that achieves benefits requires physical design considerations from the logical network requirements and network assessments. A reference architecture helps to ensure that end users and other solution implementers have the tools to confidently deploy the technology. It provides the technology focus on solving factory floor challenges that can produce significant cost savings. A standard network technology can offer investment security through continuous innovation. A reference architecture leverages that by designing with future capabilities in mind so that the system can support new capabilities rather than having to replace and upgrade constantly. Knowing the current state and considering the future requirements is a critical first step. Looking at the network traffic volume, type, data, video, control, VoIP, and time criticality for process control. This will lead to bandwidth requirements, balancing the downtime cost with appropriate level of network availability, and building in redundancy in media, connections, and paths, looking for potential network security issues and identifying needs to control physical and electronic access, and creating a physical design built to proven and validated logical architectures like converged plant-wide Ethernet. Reference architectures are a key component of successful network deployments because they provide a sustainable, scalable path for the customer to utilize. So they don't have to change architectures every time their design changes. They can just add on to them with a building block approach. So Panduit provides building blocks to execute deployment, design and deployment of the reference architecture that we talked about on the prior slide. The industrial data center, zone system, and control panel solutions from Panduit are pre-engineered, thermally tested, validated solutions ready out of the box for installation. These significantly reduce the risk associated with deploying what for some customers will be a brand new reference architecture. Together, Cisco Rockwell with the logical architecture, Panduit with the physical layer deployment provide the channel and our end users a fail-safe, low-risk deployment option for their Ethernet IP networks. Moving forward, we're going to touch on a real-life example, a customer that's deployed the logical CPWE architecture along with Panduit's physical layer. A metal processing company in North America with worldwide operations in 30 countries, manufacturing components for aerospace, extrusions, and oil and gas drilling products. The company is recognized as an industry leader, introducing, directing new business opportunities and markets across the globe. Their business objectives are common to many manufacturing plants looking to increase productivity by leveraging impact of IoT on manufacturing operations and opening up breakthrough roles in untapped markets. They wanted to ensure quality improvements to minimize risk, provide predictable maintenance, enhance network security, enable process video capabilities, improve visibility of process control data, and improve energy utilization. The project: redesign and build a new process control network infrastructure for a multi-building industrial manufacturing campus environment. We began by assessing the needs and challenges like documentation, internal resource limitations, budget constraints, security, system availability, future readiness, and overcoming ad hoc, do-it-yourself in-house approaches. The focus then turned to the physical network design process. Redesigning and building a new process control network would involve standards-based design elements to comply with current regulations and required the company to focus on key needs such as choosing the right framework of logical architecture, selecting the media type and addressing environmental considerations, developing a phased plan for network deployment, and planning for managed switch deployments. Partnering with Panduit helped the company apply the proper design attributes to the complete physical layer of its new process network. It also helped the company consider varying environmental factors, meet regulatory compliance mandates, optimize operational systems and performance, and reduce deployment time, operation, and maintenance repair operation costs. To accommodate the company's financial constraints, Panduit helped establish a realistic budget that met the needs of this growing company with a phased plan for network deployment. The solution Panduit recommended consisted of an integrated network zone system, micro data center, and control panel solutions. It is comprehensive from the control room to the machine control panels and included a network grounding and bonding infrastructure. This offering allowed Panduit to provide joint engineering and product development, interoperability, testing, and enhanced infrastructure design through strategic partnerships with Cisco networking and switching technology and Rockwell Automation. And the winner is, for best results based on vision, strategy, and execution, everyone. The customer won, Panduit won, distributor won, Cisco, Rockwell Automation partners also won. Through proven methodologies and best practices that were applied to effectively manage risk to the company's physical layer, mitigated problems in the physical infrastructure systems, reduced the cost of ownership by improved scalability and better service management. Speed of deployment by up to 75%, mitigating the risk of downtime, minimal chance of failure effect in production due to high level of redundancy. Active equipment delivered within an optimized physical layer for consistently high network performance. Protection from shock hazards and allowing clean segmentation between the upper level plant network and the machine level network helped maintain network SLAs. Panduit understood the importance of the logical and physical topologies to meet system requirements, identified in-house capabilities to maintain infrastructure, and future growth needs when suggesting solutions, and increased its engagement as the project lifecycle evolved into the deployment phases. Due to the support of our valued strategic alliances with Rockwell Automation and Cisco, as well as our distribution partners, together we can help you deliver industrial automation solutions from enterprise throughout the factory floor.